Hey, hi, Rajan this side. Welcome back to the channel. So today we'll discuss all four problems asked in today's LeetCode Weekly Contest for 76. Let's look at first one. You are given integer nums and you have to choose three elements a, b, and c from the nums at distinct indices such that the value of expression a plus b minus c is maximized, right? So essentially we have to find out the maximum possible value of this expression. If you look at here, your constraint, like the length can only go up to 100, right? So we can easily apply order of n cube solution. So what we can do, we can choose any three indices and we can find out the value of this expression, and similarly we can update our answer, right? It's easy problem. Let's directly look at the code. So this is my nums array and this is the size and this is my answer. So initially the answer I have taken is like int mean, right? Because we have to find out the maximum possible value of the expression. Then what I'm doing, I'm going through each possible values for the first index, then second index, then third index, right, from 0 to n. Just check if all these three are unique. So like to check if all these three indices are unique, you like check if I is not equals to j is not equals to k, and j is not equals to I. If that's true, means that all these three indices I, j, and k is unique. And once all the indices are unique, we can find out the value of the expression. The value of expression is nums of I plus nums of j minus nums of k. This is nothing but similar to a plus b minus c, which we have to find out in the problem statement. So yeah, just update your answer. Answer is equal to maximum of answer comma nums of I plus nums of j minus nums of k, and at the end return your answer. So yeah, that's all about the first problem. Now let's look at the second problem. In second problem, you are given a string s that consists of only characters a and b, and you are allowed to repeatedly remove any substring where the number of characters a is equals to number of character b, and after each removal the remaining parts of the string are concatenated together without gaps, and we have to find out the minimum possible length of the string after performing any number of such operation, right? And we know what is substring. So let's take the example. Let's take the first test case. So you have three number of a and three number of b, right? So you can easily remove whole string itself because the number of a is equals to number of b. So the remaining length of the string is 0 minimum. Here there is no b character, so like you cannot remove any substring. So your output is 0. If you look at here, number of character a is equals to 2, number of character b equals to 2. So you can easily remove this substring. So the remaining string is just a and the length is 1. So let's see how we can approach it. So in second problem, it says that we can remove any substring where the number of characters a is equals to number of character b, right? So let's say count a would tell you the number of characters a present in s is the original string, and similarly count b would tell you the number of character b present in s. So if you notice it here, let's take an example. Let's say you have a b c, no c, a and all, right? If both are present, like if both character a and character b are present, there must be a place where two would be adjacent to each other, right? So we can easily remove them. Similarly, see here, we can easily remove them. What you left with a and a. What it means? It means that we can always form a pair of a and b. We can always form a pair of a and b, and we can easily remove them. So what you will left with either all characters a or all characters b. So what will be your answer in that case? Your answer would be absolute value of count a minus count b. This is your answer. I can prove that. So so the proof is you can always form a pair of two adjacent a and b, right? Because since this is a string, so if a and b are present, then there must be a pair where a and b would be adjacent to each other. So we can easily remove them. We can remove all pair of a and b. You will left with either all a or all b. So what it means that we can form a pair of minimum of count a comma count b. So we can easily form a pair of count a comma count b. For example, let's say here you have count A equals to 1 2 3 4 and count of B is 2, so we can easily form a pair of 2. See, one pair is here, one pair is here, so your answer is nothing but total. And so either you can for there could be two formulas. One is n minus minimum of count A comma count B into 2, or you can easily write it in another way, absolute value of count A minus count B, because we can easily form a pair of two adjacent um, A and B, right? So what you will left with either all A or all B, so it would be count of A minus count of B. So yeah, it's up to you whether you apply this formula or this formula. So I have applied this formula, so right. So yeah, let's look at the code now. Here is the code of second problem. So you are given a string S. This is the length. This is count A, count could be. Count A would tell you the number of times character A is present in S, and count B would tell you the number of times character B is present. So just go through all the characters in S. If character is equals to A, count A plus plus, otherwise count B plus plus. Then to make sure both the values are exactly the same, because we know that both values exactly going to be same, right, as per the explanation part. So it could be either this one or this one, it's up to you. Just to show you that these two are like essentially the same, I have added an assert here. So assert this value must be equals to this. So if these two value won't be equal, it would give you a runtime error, because if these two value are unequal, this result would be a false, right, because these are the equal operator. So this will return you false, and assert false will always throw the runtime error, right? So but it won't throw runtime error because we know that these two values are going to be the same, right? And at the end return your count A minus count B. It could be like, so it's up to you whether you return this or this, then because both are exactly the same, right? Because we know that minimum of count A comma count B is the number of pairs we can form of A comma B, and in each pair you have two characters, character A and character B, so multiplied by 2. So these many characters like you can remove, so just n minus this would be the leftover characters, right? And similarly count A minus count B is also the leftover character. So yeah, that's all about the second problem. And now let's look at the third problem. In problem number 3, you are given a positive integer n, and for every integer x from 1 to n, we have to write down the integer obtained by removing all zeros from the decimal representation of x, right? And we have to return the integer that denotes the number of distinct integers that we can get. So for example 10, so from 1 to 9 all are unique, but for 10 if you remove zeros, because we have to remove zeros from the decimal representation, right, so it would be 1, and the number of unique integer that we can get is just 9, because 1 and 1 is duplicate. And for 3, 1 2 3. So it's a good problem. Let's see how we can approach it. To solve third problem, what I have done, let's say this is my given integer n, let's say 2 3 5 1 0 1 0 4 and 2. Let's say this is my given integer n, right? And we have to find out the unique numbers if you iterate through 1 to n, 1 to this number, and if you remove all the zeros, then whatever number you get, you have to find out how many distinct integer we can get, right? So let's say the length of this integer n is L, for example, right? So first what we will do, we will try to create integer of length 1, and we can find out how many unique integers that you can get, right? Then we can find out all the unique integers for the length 2, similarly for length 3, for length 4. Let's take an example. For 1, how many unique integer you can get? 9, right? From 1 to n. For 2, how many unique integer you can get? 9 into 9. Let's see how. For length 2, we know that none of the integers should contain 0 in the decimal representation, right? Because 0 would be removed. So how many options are there to keep this number? 9 possibilities are there, right? From 1 to 9. Similarly, how many possibilities are there? 9. So total number of ways is 9 into 9, because we cannot put 0 here, right? So they are only from, like, the possibilities are only from 1 2 and up to 9. So there are 9 ways to keep the number at first place, 9 ways to keep the number at second place. So the total 91. Here 9 into 9 into 9, exactly same way. For 4, 9 into 9 into 9 into 9, right? So it's nothing but 9 to the power 1, 9 square, 9 cube, 9 to the power 4. But this will only go from 1 to L minus 1, right? For L, we cannot keep all integer n, right? Because your form integer should be less than or equals to 9. It cannot be more than 9 because we have to go from 1 to n. So that's why in the first step, what we will do, we will first find out how many integers we can, like unique integers we can get for length 1, for length 2, for length 3, up to length L minus 1, right? That's the first step. And your answer would be the summation of these values: 9 to the power 1, 9 to 9, 9 square, 9 cube, 9 to the power 4. Now in second step, what we will do, we will try to find out how many integers are there whose length is L and doesn't contain any 0 and less than or equals to n, right? Less than or equals to n, length n, and no 0 at all. So that's the first step. I hope you understand. If you didn't understand any part, please write a comment. I'll resolve it. So let's see what we can do in the second step. So your integer was this one, right? Yeah. So this was a given integer. So for this test case, your answer is nothing but 9 to the power 1 plus 9 square plus 9 cube plus 1, 2, 3, 4, 5, 6, 7. 9 to the power 4 plus 9 to the power 5 plus 9 to the power 6. So these are the different interior that we can get for length up to 6, right? So the only thing which is left is to find out how many different interior that we can get for length 7. Like 7 is the length of the original integer, right? So for length 7, such that the integer is less than or equals to 9 and doesn't contain any 0, right? So to approach that, what we can do, so let's consider a case where when you have let's consider an integer where you have 2 and 3 at the first two place. In the third place you have 4. 4 means like the less than the original digit. So here the digit is 5, but I have kept 4 here. Then you have 4 unplaced digits, right? What are the options you have to keep the digit as these places? These are either from 1 to 9. See, because this digit is 4, right, which is less than 5. So like then these digits could be anyone from 1 to 9. Let's take an example. Let's say you have 2 and 0, 2 and 0, 20, right? If I kept 1 here, then what are the options you have at this place? Either from 1 to 9. See, 1 1, 1 2, 1 3, 1 4, 1 9. All these digits would be less than this digit because your current digit is less than this. So whatever number you keep at the second place, your total number will always be less than the original number. That's why if you keep any of the digit which is smaller than the original digit, for the latter digits, like for the digits on the right side, you can keep any of the number from 1 to 9. See, all the number are less than this. Similarly here, if you have 4 here, then what are the options you have? 9 to the power, let's say the current index is I, then and I could be from 0 to L minus 1, right? It's a 0 base index. Then how many integers you have on the right side, which is n L minus I minus 1. L minus I minus 1 is the number of digits on the right side. So if you keep a digit which is smaller than the original digit, then how many options you have? You could be like you can keep any of the digits from 1 to 9 and any of the 4 place, right? So 9 to the power here, which is 4, but like in the generalized case, in index form, 9 to the power n minus I minus 1, right? So here it's 9 to the power 4, but like in the generalized case, this is not L and this is L minus I minus 1. So L is the length of the original integer and I is the current index and I minus 1, right? So yeah, similarly, I mean, I hope you understand what I'm doing exactly. So what we can do, we can go through each of the index from 0 to L minus 1. We can try to first keep smaller digits. If you keep the smaller digits, what are the options you have? 9 to the power L minus I minus 1, because if you keep smaller digits, we can keep any of the digits from 1 to 9 and at all the places on the right side, right? That's why it's summation of n to the power L minus I minus 1, right? L minus I minus 1. And yeah, that's all about the explanation part. I hope you understand. And like, so even if you have some missing pieces, once you look at the code, you would understand everything, right? So yeah, let's look at the code now. Here is the code of third problem. So this is a given integer n. So first convert it into a string, then find out its length. And this is my answer. So I have divided it in two parts as per the explanation part. The first step would be to find out all the distinct integer for smaller length compared to L. So for length 1, 2, 3 up to L minus 1, your total number of ways is going to be 9 to the power length, right? Because we can keep any of the digits from 1 to 9 at the at all the places. So your total ways is going to be 9 to the power length. Now this is the first step for length up to L minus 1. Now for L, what I have done, so this is the second step. I created a function for that. So the name of the function which I have given is count same length with no zero, because there shouldn't be any zero at all for length L, right? So if you see here, what I'm doing here, first find out its length. This is my answer. Now what I'm doing, I'm going through all the indexes from 0 to L. This is my current digit. First try to keep the smaller digits. If you're for let's say d is the digit, so for x is equal to 1, x is less than d, right? So for 5 I'll be going through 1, 2, 3 and 4. And we already have discussed in the explanation part that if your current digit is smaller, then for the remaining digits you can keep all the so any of the digits from 1 to 9, right? So your total number of ways is 9 to the power L minus I minus 1. So answer plus equals to 9 to the power L minus I minus 1, because L minus I minus 1 is the remaining digits on the right side, like as per the indexes, right? So yeah, answer plus equals to that. And if your current digit is 0 itself, then just return your answer, because we cannot do anything beyond that. So, and after that, otherwise there would be one corner case that would be left. So let's consider if your original string S does not contain any zero at all. For example, let's say let's say your S is nothing but 1, 2, 3, 4, 5. So it doesn't contain any zero, right? So this case would be missed here. That's why just increment it by 1 if there is no zero at all. Because here if you see what I'm doing here, I'm trying to find out the small, so I'm keeping the smaller digits, right? So it won't be handling when all the digits are non-zero. So yeah, for that case just increment it by 1 and at then return your answer. And I have also created a power function that to calculate a to the power b in log n, because just to save the complexity, nothing else. Yeah, that's all about the third problem.